So I'll just go back. So basically, when I first walk in, once I've established that all the jobs are ready to measure, arcs are on, benches are in, power points are in position, then I can check measure. I'll always start with the bench first, and I'll level off the bench. And if there's a 2 or more mil run out, then I'll create that shape in the drawing, and then I'll measure up for my heights. And then if the reference point from there to there being 2 mil rake corresponds to the height left and right, then I know the overhead's a plumb.
Yeah. So if this bench is out of level by say 5 mil,
yep,
and that's your starting point there, that's your 0, 0.
Yep.
So you come up 5 mil here, then that's your X.
That's correct.
And then you go Y from that.
That's correct.
And then you add the 5 mil and rake it.
Exactly right,
yeah.
mate. Exactly right. So hypothetically, if it was going down 5 mil here, and this tight size was 700, I'd be looking for 705 tight at that end.
Yeah.
If it wasn't, if it was 701 or 699, it's a parallelogram. Yeah. So it's running the other way. Yep. So once I've established that, I deduct my deductions, being 4 to 5 mil, depending on situation, but that's generally how I measure tight minus 4 or tight minus 5 mil. And I'll do one panel at a time. Do that panel on the height, and then I'll work to my widths. Now, whether we're going to the bench or the arc, if we're going to, when the bench is fairly close to the architrave, I still check the arc line. And the reason being is if the arc is out of plumb by 5 mil, and you've got a 20 mil gap there, and then you end up with a 25 mil gap there, Mr. Smith picks it. Yeah. So I actually create a shape so it follows that line, so it's an even 20 mil gap the whole way up. Yeah. So I'll establish whether that's plumb or not, and the same on this side here. And then I'll draw it in the drawings to suit, and then I'll measure obviously width tight at the bottom, and then width tight at the top, and then I'll actually jot that size down. So what I'll do when I'm doing my chip measuring is just down the bottom corner here, or wherever you like, I'll write down here 2051 hypothetically, bottom, and then T for top, 2049. So you're not deducting and then, oh shit, was that, did I deduct at the top, did I deduct at the bottom? You know, so you've got you're looking at it going, right, that's tight top, that's tight bottom, and then you deduct your 4 from there, so that equals 2047 from 51 and 2045 from 49, and then you correspond that to your rakes. And if your rakes don't quite add up, you might need to tweak a mil here on the rake or tweak a mil there on the rake to make the panel work, or just double check yourself at the levels and go, oh shit, that was a 4 mil run out, not a 5 mil run out, or whatever it may be. Always fit your large back panels first. Okay, so in a situation where you've got a wall here and you've got your wall there, if you put your sides on first, what's going to happen when you try and put the back one on?
Yeah. You're
going to scratch these panels. Alright, so we want to put the back one in first, and then you deduct your 10 millimeters, 6 for the splashback and 4 for the glue, off your type size to your architrave.
Alright, quick question.
Yep.
What if you've got a big bow in that wall?
Yep, well you need to check and establish everything there. Now in this situation here where we have,
there's a method hunt there.
Okay, so what we do guys is we hook the tape onto the bench, and then we grab our little 600 level, and then we level down to there. We want the whole 6 mil glass sitting on the bench, plus a mil or so for, you know, because you want it just come sneaking forward a little bit. So rather than deducting 10 off that size, I deduct 7, 6 plus an extra mil just to be on the safe side. So hooking it off that bench line is 90, 790, okay? So I'd make that 83. Now, if I didn't do that, if I went hard to the wall, and that's 800, and I made it, my standard 790, the splashback's going to want to try and fall inside the gap.
Yeah.
Alright, so you've got to sort of try and imagine the glass and where it's sitting. It can get tricky in situations where you've got brickwork inside here and you're almost measuring off invisible lines, and you've got to try and, okay, well we can pack that up there, I'll make that level, and it's brick's hard as opposed to doing, this is grass, you know, doing all the substrate work is fantastic. It falls in every time. So in the event that you haven't got, once you've established the wall's straight and or a bow, then you measure it accordingly off your your back wall, and then you deduct your 10 or whatever's required to pack it off the
Yeah.
wall. So for example, if we're going underneath and back up, which is typical, when I measure them, the architrave here and here, I'll add a mil. Now the reason I'm adding a mil is because this panel coming into this architrave is going to be off by about, I normally allow 2 mil clearance. So this is going to be off 2 mil, that'll be off, that'll be fairly tight that size, sort of 1 mil or so, because we've got that return panel. But it basically closes the butt joint in, it closes it up. You've got an option to sort of, to tweak it in and get it nice and tight. Whereas I've seen guys, sort of deduct a few mil off that tight size, and it opens the gap right up.
So you'd have the join there and then. So you'd have a strip there?
Correct.
Yeah.
Correct. Now, the other thing you'll have to work out, and would be advice from myself or Marvin, is what can and can't be done. Okay, so the rule of thumb that you can work off is half the body of glass as an aspect ratio. Okay, so when you've got 700 here, okay, you don't want to remove any more than 350.
Yeah.
Alright, and the reason being is that when it's not cutting it, it's toughening it. When it goes through the toughener, we heat it up to about 650 degrees Celsius, then cool it rapidly. And in the chiller, the skinny area here twists and warps and blows up. We lose the whole panel.
Yeah.
The toughener's down for 48 hours. That's a nightmare. So we know the parameters on what can and can't be done.
So it can't have more than 350 cut in it.
Half the aspect ratio, whatever the size is. So if it's a metre, you want 500 body.
Yeah, okay.
Yeah.
Oh, yeah.
Alright, so here, obviously that's, not even 100.
Yeah.
As soon as the drawings go to us, we'll just flip them straight back. So, I'll give you another scenario. So in a situation where Mr. Smith wants no joints, everyone does, you try and please everyone where possible. And that window height is at 350 or 400, so you've got plenty of meat in the panel, then we can do it in one piece. Now how we measure these is we've actually got to add rather than subtract off this size here. So when you've got a range hook scenario like this into a T-shaped panel, you're deducting 5 mil, okay, off your tight size. So you've got 2.5 mil gap here, 2.5 mil gap there, and then you measure that tight, and you measure from there to there tight. And then when that comes in 2.5 mil, it also comes in 2.5 mil off the wall, off either side, and that's specified in my drawings, which I've given yourself. In this situation, it's opposite, okay? So imagine being the glass, you want clearance of 2.5 mil on either side of the architrave. So we need to add material as opposed to deduct. So at 1051, we want to make that 1056 as the cutout size. And obviously you need to level it all off and make sure that it's the same measurement there, which is not, it's 49. So we need to find our 2 mil and create that 2 mil shape so it follows the arc line. If it's 1 mil and 1 mil, ignore it, you won't get it. You'll only get 2 or more. Okay, so in this situation where it is 1 on 1, you'd probably make, rather than adding 5, you might add 6, so you end up with clearance.
So 2 mil, anything over 2 mil out of whack, and then you draw it to suit.
2 or more. Yeah. Generally, 3 is sort of the industry standard. A healthy 2.
Yeah.
If it's sort of getting up near 2, maybe ignore it, but a healthy 2, 2.5, put it in.
Yeah.
For the optimum fit.
And you put a radius on those internal corners?
All glass, when it goes through the toughening plant, must have a radius the same thickness as the glass. So 6 mil glass is a 6 mil radius.
Yeah.
Otherwise, it won't go through the toughening plant.
Yeah.
It doesn't twist and warp, it fractures. It's a weak point. You can't have a square internal cutout
That's fine.
on glass.